Mr. Tom Hull from the Florida Polytechnic University here in Lakeland. So Tom is the Vice President and CIO of Florida Polytechnic. His talk this morning is on the global impacts of 3D printing and innovation, a view from Florida Polytechnic University. So Tom is a leader in Florida Polytechnic's Technology Services Department, where he plans and implements technology systems at Florida Poly to reflect and enhance the cutting-edge 21st century teaching, learning, and research environments at the university. Tom served as the CIO for several universities over his 30-year career. Most recently, he was the Vice President and CIO officer at Pace University in New York City. He was also CIO at Virginia Commonwealth University and Siena College in Albany, New York. His background includes strategic technology planning for IBM, where he was an executive director for IBM Global Services, and he's held similar posts with the U.S. Department of Defense. Please join me in welcoming Mr. Hull.
Good morning, everyone. My presentation is the overview of the Florida Polytechnic story. And I first of all want to thank Dr. Harvey Hyman for asking me to come here and present. Dr. Hyman is the lead professor at Florida Polytechnic University. I also want to thank Najeeb for asking me to present. Najeeb, many thanks, and it's good to be here. So I look forward to telling you about the Florida Polytechnic University story, how we got started, how we got chartered, and some of the innovation that we went into in a very short order. So first of all, the overview and the vision of our university. We were started as a very good idea from the governor of the state of Florida. There were several politicians, a lot of people that saw the need for the state university system of Florida to have a STEM-focused university. If you look at other state university systems, SUNY, the Cal State system, and so forth, there is a Polytechnic University in each one of those state university systems. Cal Poly has gotten to be so popular now, they're ranked in the top 5 of U.S. News and World Report of top universities in the country. So what Florida said is, well, we're looking to build a high-tech corridor right in Central Florida between Orlando and Tampa. And the idea is to put a university as a hub right in that corridor. So it was a perfect time, perfect place, and I think the politicians, the economic development folks in this area saw the opportunity, and based on that opportunity, they took advantage of it. And that was a little bit more than 2 years ago. So the governor said, let's build this university, and the first thing that we did, first thing that they did is they got a person named Ava Parker, who was on the Board of Governors. She got started in around the May time frame. She hired me in the July time frame about 2 years ago. And one of the first things that we did was we built a business plan. So with the Board of Governors and our Board of Trustees, our business plan was all about innovation and a startup culture. So in other words, when you build a university that gets started the year before it's going to open, so we're talking 2013 to 2014, there's a lot of work that has to be done. There's a lot of very relevant plans that need to be put in place immediately so that we're on a path, we're on a course that's going to charter us into where we need to go as a startup university. We built a mission and vision, a strategic plan, and again, the charter that was sort of put upon us, but we also helped to create was, we wanted to be a modern, advanced technology campus, 500 acres right in the middle of Florida. We wanted academic programs that were STEM-focused. Again, a little bit of modeling as compared to the MITs, the SUNY system, the state university system in Texas, and the California state system. The other thing we wanted to do was technology industry collaboration, and I'll talk about over 75 corporate partners that we put in place just in the short time that we've been open. So we'll talk about that in a second. All right, so when you talk about a business plan for starting a new university, it's first of all, there's enough state funding to get you started, but at the same time, what is it that you're really chartered to do? What is it that's going to make you different than the other 11 state universities in the system? So when you think about that, you've got the University of Florida, Florida State, University of Central Florida, Florida Atlantic University. You know, you've heard of all the other 11 state universities in the system. Ours is the 12th in the state university system, and again, we're the STEM-focused, supposed to be innovative and entrepreneurial, and when students go through our programs, which I'll talk about in a minute, they're niche-based technology programs. We're not the run-of-the-mill College of Engineering, the run-of-the-mill College of Computer Science. It's different. It's a niche-based, market-driven university with education that is built around innovation. So if you look at our business plan, I just highlighted 4 different areas in page 1, page 14, page 2, again on page 14. Innovation occurs when you say, hey, we're gonna go after this. We're gonna start this literally from a green field, really a sandy field of 500 acres, right in Central Florida, where there was nothing, and now there's a university there, and the mindset, the vision behind this was all about technology innovation, and the latest trends in the industry and how it relates to education. Okay, so engineer, innovate, experiences, education. These are taglines by which we had put together our vision statement, the charter, and our business plan. So, you know, taken from the California STEM Learning Network, if you look at what they want to do, it's all about, you know, innovation, innovators, entrepreneurs, engineering and math to drive innovation. If we do this right, which we're off to a pretty good start, if we do this right, then entrepreneurship and innovation are going to occur. In other words, if you start with a baseline of solid technology programs that are science, technology, engineering, and math, then from there, the good ideas, the projects, the applied research, the collaboration with industry is going to occur. And as you know, from an engineering perspective or a computer science perspective, there's 2 reasons by which you exist. Number 1 is to build new things as an engineer, or you improve on something that's existing. Either way, it's an improvement, it's invention capability, it's innovation. The other quote that I have there is from the White House. So as you probably know, President Obama, early on in his tenure, said, we're going to focus on innovation and technology, and we're going to support educational institutions that do the same. So that's something that we've also taken advantage of. Now, when you think about it, we had 2 very strong things that we needed to do. We needed to start the university in a short period of time. So the promise that was made to the state of Florida is that we were going to start teaching courses by the fall 2014. Well, so we had to move fast because I was just hired the year before, as well as some of the other leaders at the university, including faculty. The other thing that we needed to do is to be different. We needed to be, if you will, entrepreneurial and answer the question, what is it going to be different about this university? So with those 2 things in mind, around the December-January timeframe of 2013 going into 2014, we said that we're going to build innovation labs and technology that are going to support the curriculum and support applied research and support these industry partnerships. So the idea was to have modern classroom technology. The idea was to have things like a digital library. So if you go to our campus, you're not going to see a big building that's 4 stories high that has 1 million volumes of books and so forth, and periodicals. It's a digital library. We still have access to all those things. In fact, you can get the hard copy of all those things with partnerships through a virtual learning network and a digital library consortium. So we're able to do that. It's just that we didn't put the, if you will, the resources into that sort of thing. We went to a digital library, which has been written up in a couple of different journals. The other thing we did is we said, well, we're going to put together innovation labs. These innovation labs are, first of all, they're going to attract students. And second of all, it's going to give the university and its faculty a place to sort of call home. It's going to be where they use resources in order to teach the courses and do applied research. Number one was the supercomputing complex, again in collaboration with Dr. Harvey Hyman. The supercomputer complex was intended to have, first of all, hands-on experience with the students for high-performance computing in their first year. We're talking about freshmen, sophomores, some transfer students, and graduate students. These folks are able to use virtualization in their projects, hands-on with a supercomputer and student data center room that is actually pretty unique in universities. We started that idea, I would say, in the January-February timeframe. We had it designed by the end of February in 2014, and it was up and running in a brand new lab that had water cooling and all the right environmentals by June. So between February and June, we made that supercomputer complex happen. And that's in the state acquisition process in the state of Florida, which if anybody's been through that, just to get that idea on a piece of paper takes about 6 months. So that was remarkable. The other thing, which I'm going to talk a little bit more on later, is the RAD Makerspace, the Rapid Application Development and 3D Printing and Modeling Makerspace, which I'll show you a picture of. This is the largest 3D printing innovation center in the country. So we partnered with folks like Stratasys and MakerBot and 3D Systems. And we've got an innovation center there that can be used in intro to engineering, engineering design, even into software engineering for rapid application development. These processes that students can use to learn things like CAD drawing software, 3D simulated software. Now there's, even things like Photoshop are having the capability of creating 3D models of objects. And then we can prototype them immediately right in our lab, which students can walk away with. We'll talk about a special project that went on there. The others were a cybersecurity lab, cyber gaming and digital media lab, entrepreneurship lab, VTC robotics lab, which is a virtualization technology collaboration lab, and a new health informatics lab, which just got started in the last couple of months, and partnerships are coming forward with healthcare centers and healthcare providers in Central Florida, and then top-tier industry partnerships around the country. Just a quick view of our flagship building. If you've ever driven on I-4, which is the major highway that goes between Orlando and Tampa, on exit 41, you can't miss it. We're right off the highway. Again, it's 500 acres. One of the main buildings there, our flagship building, if you will, is called the IST building. It's the Innovation, Science, and Technology building. And in that building on the first floor is where our innovation labs exist. Again, that's where those labs are. And if anybody is interested, if you ever are in Central Florida, if you live here and you want to take a tour, if you want to talk more about any one of these labs, feel free to reach out to me, and I'd be glad to show you around. Okay, so the Florida Poly University programs. What we started out with this brand new university was a College of Engineering and a College of Innovation and Technology. In the College of Engineering, we started out with graduate degree programs, Master of Science, Bachelor of Science, and engineering disciplines, if you will, that you would recognize. Now, what we did, which I think was very clever, is that we put together what's called concentrations. So in our engineering program, we have a nanotechnology concentration. We have concentrations that are related to materials management, logistics and supply chain, and so forth. In the College of Innovation and Technology, also graduate degree programs, Master of Science, Bachelor of Science, but also concentrations that are unique to what we see that's being driven in the marketplace. Big data, cybersecurity, gaming and simulation, those are very popular concentrations in the majors. And I'm going to show you the 3D print lab here in a second. Outcomes. Here's what we want to make happen, right? With Florida Polytechnic University, we're what they call real-world university. In other words, We want to be that hands-on, applied technology university. So the students that come in, they work as individuals, but they also work as teams. In their first year, they'll do team-based projects that are both in engineering and the computer science, innovation, and technology curriculum. Critical thinking, internships. We were just talking, in fact, I was just talking to the folks over here at MITRE that have an intern that's just coming out of the first year at Florida Polytechnic. There's several other industry partners that have done the same thing. Entrepreneurship. We want students that go through their projects, whether they're freshman, sophomore, graduate degree program, or bachelor's degree, that think innovatively. We want them to consider starting their own company based on products or ideas that they come up with, and we'll help them do that. And applied research, which is big. The president of our university comes from MIT Lincoln Labs, so he's national lab, research-based mindset, and so the applied research part is definitely up his alley. The thing that I would focus on, for the remainder of this talk is the RAD Makerspace, which is the innovation lab, which it's 3D printing, 3D modeling and design, and so students have access to a lab that has over 55 3D printers and scanners that also do 3D scanning. So these scanners can take an object, scan it. Depending on the object, it may take 5 or 10 minutes to do that scan. That scan results in an XYZ coordinate of an object that can be imported into a CAD drawing software package. And we have them all. We have everything from Tinkercad and Autodesk 123D to SolidWorks, Dassault Systems, Pro Engineer, Creo, Rhinoceros, all those software packages that are now out there and growing to do 3D printing and 3D object development and prototyping. Those are available. We have students that are already certified. We're running summer programs. In fact, we've actually started an international consortium of 3D technology, which is something that I think is hitting the sweet spot in both higher education, K through 12, and even nonprofits. When you think about libraries that want to get into the Makerspace and 3D printing program where they have that available as a resource for their libraries. And then, of course, you go into government and corporations as well. Knowing IBM and Lockheed Martin very well, there are advanced researchers and scientists that as they come into IBM or Lockheed Martin, they get their own 3D printer, and their job is to create prototypes and designs that actually can be shown and demonstrated based on whatever research that they're doing. One of the best projects that I thought came out of the spring semester in the 3D printing space was a student innovation project called the Levitating desk lamp. And this lamp, or this project, was developed by Dr. Chris Yakimishin. And Chris is a superb engineering professor. He has 50 patents. He's worked at GE R&D. I believe he might have spent some time in Lockheed Martin and other places. Very distinguished engineer. And his idea with the students was to give them the opportunity to make a project that from the start to the finish was their design. It included a COTS-based, a common off-the-shelf based unit, which was, if you will, over on the left-hand side of the slide. And that is a powered unit that is again, it's a base unit that the students were able to acquire. We actually bought it. And then in between that and what they were designing is a levitating area, which was based on electromagnetism. And their project was to build a lamp of their own design that levitated over that base unit, and it could be powered on and do whatever it want. Some students made them spin. Some others were, blinking lights and some other things, which included a printed circuit board design and, again, what would have to be a unique design for that student lamp. So the aesthetics, the technology, everything came into play as it should for a very good engineer. So the student projects, it was a phenomenal result in this engineering design course. There were 98 unique printed circuit board designs that were fabricated and again, this was student projects that a lot of them were just freshman students. You know, there's many places that this may wait until a junior or senior type of project, but Chris had them doing this in the first year of their engineering program. So they designed printed circuit boards, Chris had them fabricated, and then that fabrication came back and was integrated into whatever was the remainder of their engineering design. As a result, there were several, I thought, very marketable products, actually. Things that could go on to Kickstarter, things that could be, entrepreneurial in nature, could be sold in the marketplace. And if you look closely at some of these slides, there's some great designs that the student came up with, things that look like a pyramid, things that were Art Deco in shape, things that rotated. There were some very large lamps that, again, were levitating over this base unit. Somebody made a skull with multiple LEDs that you could turn on. Others were just desk lamps that, again, is pretty neat because with the levitation, you can move that lamp in any direction. It's very easy to do, and it works. So to me, the students got a tremendous amount out of this, and it was all based on the innovation labs that we put in place, clever, engineering professor or professors that sort of took this innovation, the base of technology, and then just let, active, motivated students have at it. With the right direction, it was a phenomenal result. Some of the student comments. The course didn't even feel like a class in a normal sense, where I was burdened by doing the work for it. The students actually loved coming to class. This has been the most exciting course that I've ever taken, was another comment. The fact that you could bring your own ideas to class was good. The second one there, this is the first time I've legitimately had fun in a course. How about that? We were able to learn, design, build, and see an end result that was created and come to fruition. There was a lot of freedom given to the students to make their own designs. And then finally, constructing the lamp was a great exercise in critical thinking and technique. I mean, these are student comments. This is phenomenal. I think, they go back to their parents, the 18-year-old, 19-year-olds, they talk amongst themselves. There were several students that said, I want to take my design and I want to go to phase 2. And I want to create something that, again, can be actually marketed as an invention. So this was all done in the 3D Printing and Design Innovation Center. So in summary, as you look at Florida Polytechnic University, the innovation that we have intended to get started with, the charter and the vision that we want to go forward with, is fitting right into where the industry is, and I think where the governor of the state wanted us to go. So it's a project-based learning that can do well in a freshman intro to engineering class. This is particular to this engineering design class. Fewer formal class hours may increase student engagement, provided they have out-of-class access to lab resources. So there's times where I know Dr. Yakimishin would say, you know what, I'm going to lecture for 10 minutes, and for the rest of the class time, I want you working in the lab, I want you collaborating with your peers, I want you to exchange ideas, work with TAs, and so forth. And that's what the students did. The choice of the project was the biggest challenge. Technical difficulty and creative content are critical. So in other words, the students weren't just, they weren't just guided to a point where, okay, we want you to do a certain thing, and this is exactly how you're going to do it. Instead, he said, well, if you were going to respond to an RFP, right, the government says, okay, there's a grant possibility here if you build something unique that is going to light up a room. All right, well, general sort of requirement there, and the student has to be creative, and that's kind of what he took them through. And it's an ad hoc group, intersection and intrasection and intersection, so it can minimize social loafing, as Chris would say, and that's a perfect scenario, right, where the students are motivated, They actually want to work on this in their free time. It wasn't a burden to them, and that's the kind of excitement that we want to build at this university. And I think if we start with the right technology, industry partnerships, so that we're guiding the students into areas that are either going to get them a job, or it's going to allow them to be entrepreneurial and innovative, where they might be able to create their own company or LLC. So that's where we want to take them, and that's where we started in terms of the new university here in Florida. So that's a quick overview of the innovation labs, the 3D print lab, and its impact so far on our curriculum. And again, we've got great industry partnerships that include 75 top-tier partners, from IBM to MakerBot to folks like Lockheed Martin and so forth. So thank you very much for listening, and again, thank you, Najib and Dr. Hyman, for that.